Welcome to Chemistry Lover, and here I am with another revision question, and this time it is from CSIR-NET exam December 2015. The question is on a Wittig reaction, and the question is very simple. You have to solve this question within 10 seconds. How you can solve? So here I missed, here you have one sodium hydride, right? So for this type of question, when you are solving this type of question, you have to look at all the reagents what are given and their roles. So here you can see sodium hydride is given, and the role of sodium hydride would be to abstract this proton from this hydroxyl group, and that will give you this O minus and here this CHO. Now you can see, if this O minus generates in the reaction medium, that means it will have some role, right? So sure shot it will have some role. Now if you look at all the options B, from option A, B to C, you can see there is no role of this OH minus, right? There is no role of this OH or this O minus. So that means you can discard all these options A, B, C. You can see only in option D this O or this phenolic OH or this phenolic O minus is involved in the reaction, and that means you can easily say that option D will be the correct answer. So this is the trick. This is how you can solve this type of questions very quickly. Now let us see what is the exact reaction mechanism of this particular question. So in the first step you can see triphenyl phosphine is given. Now here the confusion may be, you may think whether one equivalent of triphenyl phosphine will react with this particular starting material or two equivalents. If you may think that if two equivalents of triphenyl phosphine reacts, then you may get this type of Wittig salt, and if one equivalent of triphenyl phosphine react, then you may get this one, which is not a Wittig salt, because you can see there is no adjacent negative charge over here. So you can see this reaction is cannot occur. So this is a wrong product from this particular intermediate reaction with this aldehyde. This thing never can happen because it shows a Wittig type reaction, whereas you can see there is no negative charge over here. So this is not a Wittig salt. Now let us first see what actually happens when we treat this type of compound with triphenyl phosphine, and then finally we treat it with sodium hydride. So it doesn't matter whether two equivalents of triphenyl phosphine will react or one equivalent of triphenyl phosphine will react, because let's say if two equivalents of triphenyl phosphine react, so both of this bromide will be substituted by PPH3 plus and PPH3 plus, right? Now in the next step, when you will give sodium hydride, that sodium hydride will take a proton from here, right? This sodium hydride will take a proton from here, and that will put a negative charge over here. Now when this negative charge is generated in this carbon atom, it doesn't matter in the alpha carbon atom whether it is a triphenyl phosphine plus, that is PPH3 plus, or a bromide, because it will do a elimination reaction, and that will give you this PPH3 plus. So if two equivalents of triphenyl phosphine reacts, then also you will get this, or if one equivalence of triphenyl phosphine reacts and you have a bromine over here, then also you will get the same thing. And as here the equivalence of triphenyl phosphine is not mentioned, so we may consider that two equivalents of triphenyl phosphine will react, but at the end of the reaction we will get this one. So in option A and option D we have these options, but in option B and C you don't have this. Here they gave this Wittig salt, which cannot be formed, because you can see this elimination reaction is a very fast reaction. In these options what they did is they did two deprotonation, and this is represented by this Wittig salt, but this will not have a chance to occur. Immediately after this deprotonation occurs, this elimination thing will happen. Now what next can happen? So now you have this double bond, adjacent double bond, and this triphenyl phosphine plus, and when you are adding this this aldehyde, actually this salicylaldehyde along with sodium hydride, first this deprotonation from this phenolic OH will occur. Now you have this thing PPH3 plus So now this O minus will attack over here and this bond will break, so you will have a negative charge over here. So what you will get is, you will get, here you have this aldehyde, here you can see this is oxygen. Now there are two carbons, so this is one carbon and next carbon is this. So here you have this negative charge and here you have this PPH3 plus, right? So this is now a Wittig salt. Now Wittig salt is generated in situ, and if you remove this positive negative charge, you will have a this type of double bond over here, and then between this carbonyl group and between this Wittig salt, the Wittig reaction will occur, and out of that you will get a product like this. So here you have the double bond. So this is, you can see the product B. So this is how you have to solve, but I already mentioned, or I already told that you don't have to solve the question. Actually you can just predict the product just by looking at the options, because you have to assign all the roles of the reagents, and if you have to assign the role of sodium hydride, only option D would be the correct answer. So that's how you have to utilize your time. You have to solve this type of easy questions with shorter time. So I hope that this video will help you to understand how you have to approach for a MCQ question. And if you like this video, then let me know in the comment section, share this video with your friends, and thank you for watching.